So what actually happens in real life? Well, theoretical air should be the exact amount of air that we should need for complete combustion, correct? Bobbleheads. But what we end up doing is we end up using more air in the actual processes, more air than theoretical air. Why? Two reasons. One, to control the temperature of the combustion chamber. What does nitrogen do? Good. Absorbs the energy. It is true. You want to use the same amount of theoretical air as is necessary, but you also want your combustion chamber to last long. What is cheaper, air or your combustion chamber? Air. So guess what we've done? We just put more air so that we don't have to replace the chambers in our cars as often. Nitrogen will absorb it. Okay? And number two, just on the off chance that incomplete combustion happens, we increase our chances of a complete combustion. Now, the amount of air beyond theoretical air is called and it's usually done as a percent of theoretical air. So written as a percent of theoretical air. There's also another term, it's called deficiency of air. Can we guess what that would be? Not enough. Not enough as compared to what? There we go. So excess is how much you are above theoretical. Deficiency is how much you are below. And why do we have to do it for a percent difference? Exactly, because it's whatever that fuel may be. It's percent of it down, percent of it up. Percent less than theoretical. That's close enough, right? That explains that. Okay, another term used is called equivalence ratio. It is defined as the actual fuel air ratio to the theoretical fuel air ratio. Why do we need this? We're talking about real life. What is real life? Messy and complicated. So because real life is messy and complicated, what is the likelihood that we will always have ideal combustion? Pretty much 0%, right? So therefore, it is impossible to predict what is going to happen if we just look at the mass equations that were given. Wait, where were we? Here. Get it? So the only option that we are left with is to measure the amount of each component in the product directly. And the device that's used is called ORSAT gas analyzer. Oh, the O should be capital. Do you guys want to hear the details about this analyzer? If not, they're in the book. And there's also examples. Oh, I think you guys should do those examples. Those are good ones.